Hey, welcome. Today we're going to talk about the atomic structure, and I'm going to leave you a little food for thought at the end that I hope you'll look into more and try to get a better understanding of it. So, the basic structures that you have to know are protons, neutrons, and electrons. And since this is chemistry, that's as far as we go. When you get to physics, it gets much, much deeper, and we talk about what actually makes up protons, neutrons, and electrons. But for the sake of keeping this video short, and a little simpler, let's stick with the three basic subatomic particles that make up an atom. And those are protons, which are positive. Okay, they have a positive charge, and they are located in the nucleus or the center of an atom. Then you have the neutron, which does not stand for negative. Neutral, N, neutral. They have no charge. Okay, those are about the same size as a proton, and they hang out with the protons in the nucleus. And then you have electrons, which are much, much smaller than protons. Okay, we're talking over 1,000 times smaller. The exact numbers in your reference table, I think it's 1 over 1,836 maybe. Okay, so they are many, many, many times smaller. So these electrons are negative. Okay. They are the exact opposite charge of the protons. And you need the same number of protons as you do electrons in an atom to keep it neutral. So if you have 4 protons, you're going to have 4 electrons. So you have a balance. The neutrons can change because they're neutral. So you can have more or less neutrons without affecting the atom, really. Okay, so your protons are always equal to your atomic number. So no matter how many times you look at the periodic table, carbon is always going to be 6 because it always has 6 protons. Okay, and then you can just say, hey, if it has 6 protons and it's in a neutral state, it has to have 6 electrons, right? So that gives you your second thing. And then the way you find out how many neutrons it has on average, because remember I just said it can change, right? And we'll get into a video talking about what those changes are. But you just take the atomic number and the atomic mass and subtract them, and whatever number is left over, right? So if your atomic mass is 12 and your atomic number is 6, 12 minus 6 is 6, so you have 6 neutrons. Okay, again, on average. I just want to interestingly point out a couple of things. Protons and neutrons make up the bulk, the majority of the mass of an atom, because they're so much bigger. And the electrons are just tiny, tiny things whizzing around as fast as they can, and there's a whole bunch of different things to get into when we talk about that. But interestingly, if we were to blow up an atom, not blow it up like an explosion, but blow it up in size, so that the entire atom was the size of the Earth, the electrons would be floating around way out there in our atmosphere on the Earth level. But the proton and neutrons would be condensed down to within 200 feet. So inside one football or one soccer field would be the core of that atom, right? It'd be the nucleus of the atom. And the entire atom would be the size of the Earth because of all that empty space leading up to the electrons. So I have this question for you. If the majority of atoms is empty space, and atoms don't come inside each other's orbitals, the electrons don't, how is it possible then for me to have a solid table and not be able to push my hand right through it? Or for me to fall right through the Earth if almost all of the space around me is empty space? And second question I have for you to think about is, do we ever actually touch anything if it's almost all empty space? And why does it feel like I'm touching something solid? It's just some food for thought. Maybe you can talk to your chemistry teacher about it, do some research on your own, and stay tuned in the future. I might cover that topic, especially when we get into talking more about electrons. Have a great day.